So welcome back and very good morning again. So we're going to talk about the next topic with respect to in exploring data analytics, which is actually calculating and interpreting common descriptive statistics. And here we're going to talk on the topic regarding standard deviation. Now, standard deviation is basically nothing but which shows it's a measure actually, which shows how the data is spread with respect to the mean. This is called standard deviation. Now, deviation is nothing but how the data is spread across the mean. Standard deviation is the average of all the deviations. And you have a data set, we'll have a lot of data points, and each and every data will have an individual deviation. So that deviation is how different is the value from the mean of the data set, and standard deviation is the average of all the deviations. Now, if the data set is close together, now the standard deviation is definitely going to be small, obviously. And if the data is spread out, and then the standard deviation is going to be very large. So this is a simple understanding we can definitely have. Now you can see this is actually a visual representation, and this shape is in the form of a bell curve, right? It's a curve and it's a bell curve, and we have two things: one on the x-axis and one on the y-axis. So on the x-axis we have the deviations, that is the standard deviations. And on the y-axis, we have the frequency of occurring of these deviations. Now, when you plot each and every data point, we'll have definitely a deviation, and also how much is this deviation occurring. Some deviations might be only occurring once, some deviations might be occurring very high. So these are all plotted with respect to a data set, the deviation, what is the frequency of occurring of the deviation. We will get a curve like this. Now, this is a very simple example that now when you have a visual representation of the distributions of the deviations in a data set like in such a manner, then it is very clearly understood then we are talking about the data set is very, very normally distributed. Here we can have some important understanding and if we can talk about, there is something called the percentages marked, and we can see between -1 standard deviation and -1 standard deviation. See, when 68.2 percentage, that means when you're adding 34.5 into 2 times occurring, then actually this is one first criteria which should satisfy whether when your distribution is going to be normal. And second is when 13.6% of the data lies between -2 and +2, that when you include your 68.2, then it works almost to 95.4. So 95.4 percentage of your deviation data set points lies within less than -2 sigma. That means the second criteria for normal distribution is getting satisfied. But still wait, there is one more criteria. Between +3 and -3, 99.7% of the data points have to be there. So that means almost is only 0.1% of the data, 0.2% of the data can lie outside this normal curve. Then we say really your data is normally distributed. So these are the various interpretations we should actually get with respect to understand whether your how is your data distribution, whether it is normally distributed or it is not normally distributed. Okay, so these are all told in this particular slide as I told you. Now, if you see these three curves, you can see the first curve, if you take when the standard deviation of 0.5, the standard deviation is actually less than. If the standard deviation more, you can see the curve is getting flatter and flatter because the values are getting distributed. So that is why when we have more deviation, we have more scatter and the curve is also looking flatter. Okay. Now, this is a very simple example of calculating the standard deviation for non-group data. So the following is the data. We have library books, number of books taken in 7 days, and standard deviations are taken. So first we calculate the average, which is coming up to 9. Then what we do is we plot all the data points on X, and the deviation is found out with respect to the mean. Each and every value is different from the mean. So the value minus the mean. So you'll have deviations, and if you add all the deviations, it's going to be 0. So that is why we square it and take the square root. So then we get 3.66 is the standard deviation for this rate. So thank you very much for patiently listening to us. listening to me. Thank you very much.